Okay, welcome back to C# application development. This is going to be the first video in the persistence module. And what we're going to do is we're going to work on replacing this static dbmock class with an actual database. So first of all, we're going to go over how to actually make sure that your database schema is in source control, and then we're going to go through kind of a very brief primer on T-SQL, which is used in Microsoft's SQL Server platform. So first of all, how do I ensure that my database schema, so basically the store procedures and the views and the tables and all of that, are kept up to date with any of the code that references those tables and store procedures? I do that by adding a database project to my solution. So if you go to right click on solution, you go to add new project. You can search for database and SQL Server database project will come up. If you hit next on that, you can give it a name. I've given mine abet_db. In here you can add new items, and it will automatically default you to sort of all of the types of new items that you can have. So the big ones will be tables. So just like PostgreSQL or MySQL, tables are basically the main logical unit for storing anything in the database. But it also lets you do things like create views and create store procedures or somewhere in the system. So what you want to do is first we're going to create a table. I named my table semester. So this semester table is going to hold all of the same information that my semester model originally held. So if I go to the definition of that thing, I've got an ID, I've got a name, and I've got last modified. So if I go to semester.sql, either you can use T-SQL to create the table. This is what that T-SQL looks like. Or you can use the WYSIWYG designer and does the exact same thing. So I'm going to go through the T-SQL because it is probably more confusing. So first, these are the names of the columns. This is the name of the table. DBO here is the name of the schema. So in SQL Server, schemas are basically just collections of things. So you can think of this almost as a namespace. So DBO could have tables in it, it could have procedures, it could have views, all of that. And you can group procedures and views and store procedure and tables that implement portions of your software with different schemas, or you could leave them all the default. Default is DBO, stands for database owner. So after the name, what you're going to have is the data type. So these are all SQL data types. Int, pretty straightforward. Datetime, pretty straightforward. But note that the datetime here is not the same as the C# datetime. This is a SQL datetime, and we'll see in a later video that there's a slight difference between those two things. Here we have varchar 30, so there's no concept of a string in SQL. It's all varchar or char or in varchar. So the difference between these things is that in varchar allows Unicode, varchar is ASCII. This it tells you how long it is, and so a char will enforce this length. So a char field will always have 30 characters in it. A varchar will have up to 30 characters. So if I have a 7 character name, I will not allocate the other 23 spots in the page of the actual B tree file. So this is the name, this is the data type. The third thing is whether or not you actually allow nulls to be stored in that column. So here I'm not allowing a null because this is the ID that's going to be the primary key for the table. Here I do allow a null for the name. It's common to make things default to null, but if you have kind of system level columns like last modified, where you want to make sure that anybody who goes in and modifies or inserts something into the table is providing a date stamp, you would also make that thing not null. So if somebody tried to create a new record and they did not specify a last modified, you would get an error. You wouldn't actually persist that data. So for regular columns, that's really all you need. For the primary key, we have primary key, which is the keywords that are telling you that you can't have two records in the table that have the same ID value, and the reason is because this is the primary key on the table. And identity is a special sort of addendum to the int data type. What this does is it will automatically generate values. So there are two parameters you can pass this thing. By default, they're 1, 1. But you can make it 1, 5, or 10, 4. The first number is the starting point. The second number is the step size. So here 1, 1 means that my first ID when I insert a value is going to be 1. The next one's going to be 2. The next one's going to be 3, so on and so forth. If I did this as 5s, my first one would be 1. The next one would be 6, and then 11, so on and so forth. Identity is super nice because you don't have to do the kind of cooked up weird max ID idea that we did in the controller. And so if you go back to app.js, this next semester variable, all it's doing is keeping track of what the next ID would be. So I've created 3 things. And I initially had them set to 0, 1, and 2, and so my next semester would be 3, so on and so forth. What this identity is doing is replacing this whole idea. I don't have to deal with any of the IDs. It doesn't actually matter. And we're going to talk at length in the entity framework video about how to manage these IDs and what it means to be a new entity versus an existing entity. So to suffice it to say that this is all you need to build a table that has 3 columns. One of them is the primary key or ID. The next one is the name of the semester. And then the last one is a not null last modified. So in terms of the MVC pattern, we want to make sure that the class that implements the model indeed has each of these columns. You don't necessarily have to map all of them, but most of the time you do. That model is going to get read directly out of this table rather than from dbmock. And so that's where we're going over the next couple videos. So the question then becomes, what do I need to do in order to get this to actually create a table in a database somewhere? So that brings us to SQL Server Management Studio, and I will put a link to download this and download the developer version of SQL Server in a Canvas page. But basically, what will happen is you will have to create a database with some kind of name. So the SQL syntax to do that is to create a database, give it a name, and if I execute that thing, I've already done it. If I refresh, I will see that abet.db exists now. If I go back to Visual Studio, I can right-click on this project, and I can do what's called a Schema Compare. If I pull up Schema Compare, and then I go to this, so this is the name of the project. Over here, I can select a target. I can build a connection, and so this is a recent connection. Dot is the name of your local host, so I'm running my SQL Server locally. abet_db is the name of the database. If I click that thing and I hit OK, what will happen is this compare button will become clickable, and if you click that compare button, it will run through all the tables in this database project. It will run through all of the tables that are already in this database, which we know to be empty, and it will automatically generate a SQL query to build that table. So this one is fairly simple because it's just one table. However, if you were adding a new table to a stack of 10,000 tables, this Schema Compare would tell you which tables had columns deleted or updated and all of that kind of stuff. And as we go into Entity Framework, it'll become very obvious how important keeping your database schema up to date is, because if there are any columns that are in your enterprise model that are not in the database, everything will break and you won't be able to use the app anymore. So we can go back to SQL. And so I've literally just copy and pasted this create table statement, and I can run that thing, and what it's going to say, I'm actually going to delete this. It'll take so long. So I've created this table. I can delete all of the stuff out of that table. And if I select from it, I will get the columns that I intended to have: ID, name, and last modified. I think it's because I'm connected to it. So what we're going to do first is show how to insert a new record into semester. So ideally what we would do is we would have this dbmock, and we would basically just build a replica of this in the database. We would have fall, spring, and summer, and we wouldn't have this a need for this dbmock at all. So we're going to come over here, and the first way to do that is to insert into semester. You list the column names that you need, and then you list the values that you want to go into those respective columns. So here we're going to put get date into last modified. We're going to get fall 2019 into name. The big thing to note is that SQL uses single quotes around literals. And you only are required to have quotes around varchars, but you can put quotes around other data types. It doesn't actually matter. So if I insert that record into semester, and now I select semester again, indeed I have fall 2019, and I have the timestamp that I actually created that record. If I try to do something like insert into semester name, values spring 2020, it will tell me that I can't actually do it because I've made my last modified column not allow nulls. So that's what's keeping people from inserting data that doesn't have a timestamp associated with it. So the other thing to note is that this ID is being kept. So I was doing a little bit of testing before recording. So I inserted 5 rows into this table. I deleted them, and I've added a 6th one, and so it keeps memory of exactly what the next ID is. It doesn't reclaim IDs unless you specifically tell it to, or you code your way around it. So I can delete all that stuff out, and so now I'm back to nothing. So in terms of sort of best practices around CRUD operations in a SQL database, typically what you want is you want procedures that do all of the inserts, the deletes, and the updates. And the reason is because you can encapsulate all the logic, and if there is special logic, you can make sure that a record of that is kept in the procedure logic itself. So this one is pretty simple. It's just the insert statement, but I'm taking in a name and then passing that name. And so because I've already put it into the database in my testing, it won't let me create again, but I can use alter to change the logic of the procedure. And so these store procedures act exactly like methods in C#. It's essentially just encapsulating a bunch of logic. So if I go in here and I want to use that procedure, or actually invoke that procedure, what I do is I use the exec or exec keyword, and then I use the name of the procedure, and then I pass in all of its parameters. And so here I don't have to pass in get date because it's automatically going to be whenever the store procedure is called. So if I run all of these statements and then I go back and select, now I see that I've got all of the records that I need. Selecting, you can use where and then wildcards. So the wildcard is a %sign, and so if you wanted to select only the semesters that were spring semesters, you could do that with this query. If you wanted to delete all semesters that are like a fall semester, you can execute that. I've deleted 2 records now, and so if I select, I will have no falls. And then you can also update records. So what you want to do usually is use an ID to make sure that you're getting a unique row. So here what I can do is I can update the first semester to be summer 2021 instead of fall 2019. And if I select from semester, indeed I get, oh, it's because I don't have an ID one. If I do ID 9, for example, now it's spring 2021, or spring 2020 in the database, but if I issue this query right there, now I have summer 2021 because I just changed it. So if I wanted to perform updates with stored procedures, I could do exactly the same thing. So this is a stored procedure that takes in the ID and it takes in a new name. My ID is actually going to be 9, and I can call the stored procedure with exactly the same syntax. So here I'm just co-opting this update statement, and if I call this thing, oh, it hasn't been created. I create it, execute that thing, and then I select from the semester list. I'm back to fall 2019, which is my original state. So this is the 8-minute really quick rundown of what SQL kind of looks like in terms of syntax. It turns out that with Entity Framework, you don't actually have to care about any of this stuff unless you're trying to debug, and then being able to select is really nice. Basically what we're going to do is we're going to use Entity Framework, which is a C# library that allows you to generate all of this SQL, so you don't have to care about actually knowing T-SQL as much. So that is basically the .NET ORM, and the .NET ORM will map this table structure to this model sort of automatically, and you won't have to do very much work in order to do it. So before we get into Entity Framework, I'm going to do a really quick video about how you can interact with SQL through what's called the SQL client libraries. That is for situations where you don't control the database. You can make a connection and you can actually issue T-SQL commands through C#, and that does not require you to have an Entity Framework link set up between some sort of third-party proprietary database and the actual code that you're working in. This is basically just to show you how to get a table set up. So if you are working on the 5th programming assignment, you'll want to create tables for all of the entities that you have built CRUD operations for. And those tables we will eventually either use SQL client to interact with, or we'll use Entity Framework to automatically map with the ORM. So that is the long and short of this video. In the next video, I'm going to quickly go through what SQL Client looks like, how you can use it, when you might want to use it, and then we'll move on to Entity Framework. So thanks for tuning in, and I will see you in the next one.